Welcome to the Knights Open Circuit, the IEEE UCF official podcast. I'm your host, Juan Battaglia.
And I'm Julia Lampert. In today's episode, we have Askhan Farhangi. He's a Ph.D. candidate in the Computer Engineering program at UCF and is part of the Real-Time and Intelligent Systems Lab. Ash's main area of study is time series and natural language processing and has 2 publications.
Ashkan teaches massive storage, big data, and computer communications networks at UCF. He has collaborated with the College of Medicine and the College of Education to develop different technologies. Welcome to the show, Ashkan.
Welcome. Thanks for having me, guys.
No, thank you for coming. Okay, first question, just right off the bat. What can you tell us about how your Thanksgiving went and what did you do for Black Friday and all that stuff these past few days?
For Thanksgiving, I think I did a picnic. We got a chance to visit the family. You know, this is the last week of the semester. Things go a little bit crazy, but hopefully I can catch up with my family in for Christmas. But yeah, I didn't do any binge eating, so
Mm-hmm.
Can't say the same.
No, can't say the same, unfortunately. So you are getting your PhD right now at UCF, and you also got your master's at UCF. Where did you get your undergrad, and how did and was it also in electrical engineering and computer engineering?
Yeah, I did my undergrad as an electrical engineer. At first, I think back in 2011 when I joined the electrical engineering program. So I'm very old. Back then, it was fairly the top choice of engineering, in my opinion, and I choose that. But I was always good with computers and had a good feeling about it. But however, I think even till now, there is no big difference whether you want to do computer engineer or electrical engineer, because you have to study the same and take the same requirement courses. Only the last few are different. So I'm not regretting my decision. Again, electrical engineer, I think, was a good investment to push me forward for the graduate program.
And what made you make that decision to do computer engineering for PhD?
I think the whole technology space was shifting more toward computer software and, of course, computer hardware. A good example, when I was trying to do graduate, I was hoping to do solar power, solar energy. I think it's a fairly new field. I mean, let's look at like 5-10 years ago. However, I think with the speed of technology advancement, I think computer engineering or computer science advanced a little bit more. That's to the software aspect of it. So I'm shifting more toward where is the trend, where is the need, and I finally made a decision. Again, I was doing my master's in electrical engineering too, but I shift my focus on to do a PhD in computer engineering. And transition is fairly easy because, like I told you, most of the courses are similar. And you just have to have a good mathematical foundation to survive in both.
Mm-hmm.
So what kind of inspired you to go and get your PhD after you already had your master's?
Yeah, the thing is just, it runs in our family. Everybody has a PhD. My father is a doctor, my sister, everybody. So it's kind of like pressure to get a PhD to get to their level. So it's not, I like the idea of it too. I think a lot of people, when do join PhDs, are like, oh, the name is on itself. They call PhD, but it's known as permanent head damage. The acronym for PhD. It's a very tough program, and not many people go there, and not many people survive. So it needs to be like, you need to make a solid decision. But once you're in it, it's not that bad. I think I enjoyed it more than undergrad. Difference is, I think, is in the research. In undergrad, most likely you take courses and you have to do tests. There's no much freedom in your creativity to do problems on your own, but in PhD, you're allowed to do that. Like, there are no textbooks, there's no books, you just have to read papers and write papers.
Mm-hmm. what besides your family pressuring you to do it, or are you feeling that you have to because your family has done it? What advice would you give to somebody who is thinking about getting a PhD, and what in your eyes are like the pros and maybe cons of it, other
Yeah.
than permanent damage?
Permanent head damage, yeah. So I think if you're sitting down with any faculty at UCF and you want to get interviewed for getting a PhD, they ask you certain questions. And those certain questions, I can tell you, is evaluate, do you like to do research? That's all it is. Do you like to just read papers, write papers, try to do experiments on your own without less guidance? That's the main key, I believe. So if you really like research, you like to do what is the state of the art technology, how you can surpass that, I think it's a good program for you. It's very different than undergrad and high school. Basically, you're no longer relying on textbooks and people teaching you stuff. You have to learn on your own, and which is very, very unique aspect. So I think but the way I'm structuring like this massive storage and big data class is the same. You force students to read papers, 5 of them, and write a review, same as any grad level. And of course, the final project is a research paper, 6 pages. So this just give them a little bit of touch of how it feels like if you join a graduate program in most universities.
Mhm.
So do you have do you have a specific goal that you want to reach after getting your PhD?
Yeah, so basically I love research, and I hope that in whether it's academia or industry, basically you have to figure out and toss a coin to see which ones are more suitable for you. But I really like challenges and challenging problems. So whether it's academia or industry, I prefer to do a research position.
I was gonna say, do you have a preference of what you wanted to do, like industry or
I'm like,
yeah.
I think I enjoy teaching a lot. It's just, I really enjoy like try to make something more difficult in a simple manner and try to teach the students that, and of course, ask questions. Andrew is my student, knows that I always ask questions every 5 minutes, a pause. Nobody answers, there's crickets. But that's the way I'm kind of like between both areas, but I can see myself going back to academia after a certain point of industry.
Oh, but you do want to dip your toes into industry for at some point.
Yeah, if there is a option, I'm open to it. And again, I think in terms of research, a lot of faculty and industry research are same. Even you go to conferences, a lot of engineers in that company are presenting the same material. So there's not much distinction in terms of the work you do, but of course, being a professor is like hard work because you have to deal with a lot of students, a lot of obligation that comes in your tasks.
Hmm. So you're teaching 3 classes right now, or you have 3 classes that you teach every few
Yeah,
semesters,
every
right?
semester I'm a teaching associate here. So I have an option to select courses and teach them. Usually some professors or some classes open up and university uses me to teach them. For example, for the summer, we did computer communication networks. And next summer, I'm going to do the same. And this semester was a massive storage and big data.
And but before these 3 classes, did you teach classes before, or is this your first
Um,
time leading
Yeah,
other
as
classes?
a graduate student, you become a TA and you have these teaching assistant opportunities, right? So basically, there's a professor that teaches the course, and you as a TA might cover 1 or 2 classes or hold some classes to solve problems. There comes the opportunity to try to work on your craft and try to talk with students and figure out where are they. So I think that taught me a lot because as a TA, you basically going through the grades and see the performance of students, how it goes. And I had a lot of that. So I kind of know like, when I'm telling you something, are you going to perform well on the test or not? If not, I need to emphasize a little bit more. So I think it helped me a lot to do, whoever wants to teach, you have to go through that grading period, the TA period, and finally you're able to teach the concept.
Did you ever like tutor before you became a TA?
No, I never been a tutor. I think my first one when I joined UCF in 2019, I just became a TA right after
Okay,
that.
I was wondering if you had like experience prior to that in like teaching students at all.
No, no fire. But yeah, I think it's the transition is fairly easy for grad student because most of the classes you have to go and present your work every sessions or every 2 times, 3 times a class semester. So you always have to teach your fellow students. And same thing would apply. It's very conditioned easily to teach other students in other programs. Yeah.
Can you talk about what your PhD thesis is based on?
Yeah. So basically, for PhD we call it dissertation, fancy name. It's a little bit longer than thesis. For I think for masters we call it thesis. I think mine is shifting more toward to find a good framework for time series problems. So I'm very interested in this particular subfield of computer engineering, which is time series models and time series prediction. Always been fascinated with the notion of time and how it will affect data over time. So most likely my dissertation will shift toward that. Again, dissertation, a lot of people have this feeling that, all right, I'm gonna lock myself in my room for a year behind a computer and I'm gonna look at a blank screen and have that permanent damage. But most likely you have to look at it realistically, and you're not able to do that because it takes experience to write that 300, 200 page of dissertation. So what we do is we try to split that to mini projects and conference papers that we can build upon our dissertation from. So for example, another student who graduated recently from the real-time intelligence systems lab, the lab I'm working on, if you read his dissertation, he relied a lot on probably 3 to 4 of his top work. He wrote his whole dissertation around that. So he had a very good solid foundation. And once you write or publish 4 papers, you have almost 100 pages of worth of material to talk about.
Do you mind telling us more about the lab that you work in?
Yeah, so we are working in real-time intelligence lab. It's led by Dr. Zishan Gu. We do a lot of stuff. One thing is fairly interesting for undergrad students. We have autonomous driving kit. We have F-110. So we have this car that is kind of like a miniature, but every year there's a competition to who can build the fastest car that goes around the track on its own. And it's like a competition between the race cars. So it's very similar to Formula One, but in a very smaller scale. And so what we try to do is teach undergrad students and to build their own model, and of course use artificial intelligence to guide the guide the car to go around. And sometimes you can even hit other cars. I don't believe the rules are a little bit it's getting crazy. You're allowed to hit other cars. I don't think that should be the case, but yeah, it's just a fun project for undergrads to join and work in a lab. For graduate students, we are really interested in real-time systems. So real-time system is a little bit different than time series. They both use the concept of time. That's the same, but real-time is very about predictability. You need to make sure your system is predictable. And there's a lot of theory behind it. Most of the students in our lab work on that. And of course, there's me and another student. We are mostly focusing on application of deep learning and machine learning projects. So most rely on that. However, there are some times that they rely on us and we rely on them. So there is like a field that these 2 fields are very close to each other, and that's intelligent systems part of it.
Can you explain for anybody who's listening to what exactly time series are and what real-time systems are and that sort of stuff?
Yeah, so it's a real time. Again, if you say I want to build a system that is real time, so your system needs to interact with the outside world, right? And every robot, every autonomous car, they needs to have some sensors and look at things and try to do something on that. So this is a problem because once you're trying to observe something, there is some processing time, there's some action time, right? So it's not typically real time because no matter how small that gap is, you're always going to have this delay of observing something and doing something. So real time is about predictability, real time systems. We try to make a system very predictable. So we know that 100 time steps from now, it's going to do that certain thing. And whether the observation comes or not, you're going to do the same thing. But if it comes, you try to shift your resources and try to make it better actions over time. A good example would be airplanes. They need to be very predictable. They need to be guaranteed that you're gonna always open up that wing and land perfectly. So we really care about guarantees and pointing out how predictable this model is over millions of times. You should not fail even one time. That's fatal. Another thing, a good example is these devices that is in your heart that generates the pulse. Some people have heart failure, so they need to use this device. What's that? Pacemaker, right? Pacemakers needs to be very, very real time. You need to produce that pulse in a predictable way. They should not just rely on the sensor. So it's a very hard problem to develop this system. So you need to be very, very critical about what resources do you use, the battery of the pacemaker, or maybe the pulse generation. Everything needs to be very, very fine-tuned. That's the real-time system. Time series, on the other hand, is mostly about data. And what I can tell you is over time, that part is producing a pulse. And we try to capture that value of data. So once you capture that value, you have a time series, kind of like a stock market, goes up and down. So most of the things you can do is you can predict the future or analyze the past. So analyzing past, is your heartbeat normal, or you have some abnormalities going up and down, or predict the next 100 time steps, how your heart rate is going to go up and down.
So how do you use that in your labs now?
Yeah, so what I do is this time series actually is very applicable to industry problems. So for example, we analyze financial data and we try to build models in terms of catastrophe. So for example, COVID-19 appeared and the whole US economy got down and a lot of people were changed, a lot of people credit behavior have changed. So I think the latest publication that I did was about that. And we tried to analyze the market over time and figure out, all right, the pandemic comes, here's what we saw. If another pandemic comes again, whether it's stronger or worse, how the market's going to react. So this allows the decision makers to use these models to probably mitigate the problem and plan accordingly. So this data set that we have is fairly new, but it can be used to probably, let's say a good example is the hospitals, right? They're getting this filled with patients and they're not able to hold more than a capacity, results in a lot of patients die. So if you have this model, you can predict the future. If another pandemic comes, you can plan accordingly and hopefully save a lot of people's lives.
And when you talk about using real-time systems for all these applications, do you like you said, these systems have to be, a lot of them have to be like very reliable. Is there a way that you can use machine learning to make it more reliable in any way, or how exactly do you achieve that reliability?
Yeah, very good question. So again, this is a very novel, wet ground of research that we're trying to merge and put a marriage between these two fields. So unfortunately, if you take any deep learning course, it's not reliable, it's not predictable, it's very stochastic. It happens in randomly. Even Andrew who took this course, he knows that we're using stochastic gradient descent to train the network. And I actually showed him a video of Tesla car. When the Tesla sees a person, it doesn't say it's 100% a person. This is 89%, 75%. So there is always this percentage of uncertainty in these models. So we try to do that for merge time with real-time systems, but it's a very, very difficult problem. You have to go a lot of in depth to find the right algorithms that provides that predictability and guarantees that we want. Yeah, so I think by now, I don't think your airplanes, Boeing or anything uses very, very advanced AI. You're still going to rely on real-time systems because it's people's lives. Same with Tesla cars. They're doing that for detection. However, a lot of mechanism like brakes and let's say speeding up, changing lanes are all real-time systems. They need to be guaranteed and predictable, unless they wouldn't be on the market.
Okay, so there's still a bit of a disconnect between machine learning and deep learning and reliability. But is that something that's the industry trying to close in on?
It's very hard to close that gap because first of all, the whole notion of deep learning is about trying to simulate your brain and try to build a computer that acts like you. We don't know how our brain works right now, for one. We don't know how a neuron works or what's the perfect model to build our model. And on top of that, you have to provide guarantees and find a global minimum of errors. So you need to build a model that guarantees the best model to solve this problem, which means that you need to build an AI that detects humans in the streets the best possible. So we haven't reached that. And that's an interesting problem because I don't think any AI is able to detect a human when it's snowing, when it's raining, when there is a page, let's say half of a page, or there is like a dust. These problems would make the problem much harder to solve. So again, we might be digging the wrong tunnel going through this in a stochastic way, but there might be a possibility that we could shift our focus and do something even better than this, better than just doing things randomly.
Right. But also for a lot of these problems, AI is a very good solution. Like I know that especially like one that a lot of people know about is when Facebook can recognize your face in whatever picture you put, and it can automatically tag whoever's in the picture. That's something that, and also on my phone, I'll take pictures of people and I don't even know who they are, and they will tell me that, oh, that's your family member, or that's your this is and these are all the other pictures you have of that person, and sometimes I can't even tell who it is in that picture.
They can't even detect your puppies, your dogs.
Yeah.
Name them. That's pretty interesting.
So they're better than even some humans sometimes. So in that sense, I don't know how reliable. I don't think that's something that fits into reliability, but I think that they are getting to a point where they can be better than a different or a traditional method of detecting anything.
So would you rather let's ask you a question. Would you rather to get in an airplane that is being piloted by a human pilot and has 20 years of experience, or an AI?
Can we get an AI that has 20 years of experience?
It's a very interesting problem, right? It's your life. You're sitting down with your family, you're going to Bahamas, so what if the thunderstorm appears? So algorithm works very well. So you need to simulate that environment, so thunderstorm, harsh environment for AI. What if something appears that never appeared before? So humans are there's this is gray line that again. Let me ask Julia, which one would you choose? Would you choose the pilot that is human or AI?
I would choose the pilot.
Pilot, right?
Yeah.
Because driving a car is very simple. You're on the ground. There's no just again you can stop and that would be it. But you're airplane, you're just even being in air still is very, very difficult. Like you have to measure everything. So this is something that we have to look upon. Again, it goes with the harder problem, surgeries. Of course, there's AI that does better in operation. But would you are you more interested to do the AI or the a surgeon who has more like real-time experience?
I mean, it's gonna have to be, I guess, a slow transition, but I think at some point AI already has proven that it can be better than humans at some things. So
Yeah. But there's always this like, I need to see a human, right? I need to touch his hand. That's my doctor. Okay. So
well, yeah.
very interesting how it folds out. How are we gonna make that transition? So we're living in age, especially you guys are much younger than me. You're gonna see this transition to other industries and whether humans adapt or not, right?
Well, yeah. But I think that can be said about a lot of other technologies as well, that it takes a leap of faith at some point. They slowly have to work up into the mainstream of anything.
Yeah. So let me ask you another question. This is because you guys asking, I'm gonna ask you a hard question as well. Let's say for the task of driving a car, we're having Tesla cars right now, right? What if this Tesla car run over one person intentionally, and they look at the algorithm that make this decision intentionally? There was no mistake. So what happens then? Would you buy a Tesla car, or it's just 1 in a million, right? It happened.
It's kind of like the movie I, Robot.
Yeah, right. It's a very hard, interesting topic to talk about because if it's intentionally done that, which means that
It means that it's thinking.
Is it?
Like
I
if
think
it intentionally like runs over somebody, like that's scary.
yeah, there's no mistake. The algorithm made the right choice. Just speed up over that person. Just it could happen. It's not out of the norm, right?
I mean, has it have? I don't know, but it's not it is a mistake at the end of the day, because that's not something that we want the model to be doing. So I think
Yeah.
that's a mistake on everybody. I mean, a failure like that is a failure on a lot of different levels. It's a failure on the engineers. It's a failure on probably whoever was in the car a little bit and whoever was crossing the street. And but yeah, I think that the model would need to be fixed at that point. I don't
So
think
you
you
trust
can just throw it away.
you trust the model, right? It's okay. It's just one mistake. You're gonna just 1 in a million, right? It appears. So you personally have to trust the model
Well, no, if they fix it, like that's something that
if they fix it, right? But
that has to get fixed. That can't happen again.
yeah. So with humans, if you do that, you go to prison. Then no, I don't know whatever happens to you. But for the AI, it's just one mistake. He's doing good job. He's saving a lot of people's life. Probably we humans are the worst drivers of them all. We are so bad that we killing each other every year, but huge amount of numbers. So it's interesting to see when that happens, how people react, how the general public will react. What if that person who died, unfortunately, God forbid, is a kid? A lot of people say, put a stop to this. We don't want that because that child is dead because of that algorithm. So he's the bad person, shouldn't trust it. So this is something that we need to see. How can we convince the public that these mistakes will happen? Even in real-time systems, there was a problem that engineers couldn't open the landing very well, and the system died. Or maybe it was like a machine gun or something, I don't know, just fired over a real airplane. Real-time system. So this real-time system does not using any AI at all. It's very predictable. You make these mistakes and kills people. So you have to realize, like, at one point, am I gonna make that shift, or would you like things to be human-based?
It's going to be a slow transition, but I think it will head in that direction. Well, I mean, it's definitely going to head in that direction, I feel like.
I feel like it'll be a very slow transition, though.
Maybe. But, people got on, at some point, someone got on the first, airliner for the first time and flew to wherever, and they trusted it, and now it's mainstream. And yeah, planes crash. And everybody dies in the plane. It happens every once in a while, but we still get on the plane. We still trust it. and it's just,
Yeah.
but it's a cultural thing. It's a cultural shift. I'm sure it wasn't easy at the first few people that got on those planes, and it won't be easy for the first few people who get on the supersonic jets that hopefully come at some point. It won't be easy for the people that get on the first AI controlled supersonic jet at some point, you know? So it's going to be a cultural shift, but I guess, yeah, I guess you're right. There is a lot of marketing and a lot of, I guess, a lot of dollars that go into how the public perceives a new technology, because that's ultimately what's going to determine if it's going to be adopted or not.
Yeah, that's a very interesting point. You
So I'm gonna shift subjects a little bit and go back to talking about your lab. Have you ever worked in any other labs, like besides the one that you're working in currently?
As an undergrad, I'm working in a solar power systems lab. So I know a little bit of how it works. Again, I was an undergrad back then. I worked, I think, one summer or so in that lab. It was a fairly good time. We learned a lot. And I believe you guys should come to the labs more often. Ask PhD students about problems rather than just solving your homeworks. You learn a lot about what are the current trends going on, and I think even ask about like your future, like especially if you want to go to grad school, ask a PhD student how is it, get their feedback as much as possible. They're open to talk to you. They just went through the line, and whether it's academic problem, our lab doors are always open. You can come in and ask questions.
That's actually, it's interesting you say that, because back when I was a freshman, during my first summer at UCF, I took this class, and it was called the Undergraduate Research Academy, I think it was called. It was basically just a 1 credit hour course. You just went a few days, and they just taught you everything about how to contact professors in order to do research if you wanted to head in that direction as an undergrad, and how to sort of how that whole scene works, and because it's confusing for somebody who is just going into college for the first time to know what any of that is about, and especially like all the scholarships you can get and everything like that. But one thing that they had us do is they took us to Research One, and they just showed us around a lot of different labs, and all the people that were doing work at those labs were there, just standing there answering all our questions, and we got to see a whole lot of different projects that were going on that if not we wouldn't have any idea about it unless we went to a showcase or something like that. But you don't see a lot of undergrads just browsing around a showcase. So I think it would be really nice if they had more like open house events, sort of like that, for undergrads to just come, and people can, and like the researchers can just answer their questions and see what kind of research they're doing and what a lab looks like. I think that would attract a lot more people to just want to do research, or just like at least see what it's like.
Yeah, I think that's a good opinion by you. Yeah, if I could go back in undergrad, I'd tell myself secretly do something. I would say like go to in the labs and figure out what they're doing. Try to learn a little bit from them. They're the same boat as you. They were, again, me too. I was an undergrad. I finished it, so there's some advices that we can give each other. So I think it's a good investment. Just go at least once. A lot of students just never go that. They just go to the professor's office to ask for a problem or something. But again, labs are a pretty good environment to learn something new.
Yeah, I actually used to work in the Center for Microgravity Research in the physics building with Andrew when I was a freshman. And I, all of like the grad students or like the upperclassmen always helped me out with any questions that I had, especially on homework or just talking about professors or literally about anything, like about life. They always helped me out with just questions that I had. It was really nice.
Anything to get from our research, just comment.
Yeah, right?
Distract us from our problems.
Yeah.
I have another question for you. What sort of made you decide to come to UCF for your master's and your PhD?
Yeah,
And also, did you know you wanted to get a PhD while you were doing your master's?
No, I was just I think I was gonna do masters and just call it quits. I wasn't thinking about doing a PhD. But as I go to the grad school, I figure out this is actually what I like. I like to just be read research papers and all of that. And my advisor told me like, fine with either masters or PhD, and I made decision just change from electrical to computer engineer PhD program. Yeah, I think UCF is fairly have a very strong CS department and CE in electrical, especially in Florida. We know there is a lot of sun and a lot of solar power that needs to be harvested. So it's a very good university. I advise everybody to look into these programs. And one other thing is the bigger university, the more fun things are available for us to do. The amenities are pretty good, and you're able to find your own people much better rather than going to a private institution. They have very few people in your classroom. Here in some classes, there are like almost 400 people. It's crazy.
Yeah. But were you already in Florida, or did you have to move to come to your master's and PhD?
No, I was. I have to come to America, but yeah, I think it's a good state to start with. Again, people choose to go to other states as well, but I think Florida is a good one. Depending on you have to look at like the state needs. The state requires a lot of attention in electrical, right? Um, the electrical program in this university is fairly large. Same with computer engineering and CS. So again, we don't have much technology companies in Florida compared to California, but again, there is a lot of big ones, right? SpaceX is here, NASA is here. So I think it's a good choice overall, rather than other universities.
Mhm.
So, throughout your college career, I feel like you've had a lot of years of experience in school. Have you ever had any like really hard challenges or setbacks, like while
Yeah,
you've been
I
here?
will, I will answer it, but let me ask you one question. If you could study somewhere else than here in the United States, which country or which university would you choose? You have to go away for 4 or 5 years, different language, different experience.
You can go first, Julia. You can go first.
Um, I don't know. I never really looked. Like, I really don't know any other universities outside of like Florida, mostly because I grew up here and I have scholarships for just Florida school, so I never really did research into outside of the country. So um maybe like New Zealand or Sweden, because I know they're super into green energy,
Mhm.
and that's something that I want to do. So maybe somewhere over there.
So would you rather go to the English university or like speaking their own language? So for example, Sweden, they speak Swedish, right? So
Yeah, I think I would try to learn their language because I think it's important, especially if you're living in that place. It's important to understand their language and their culture. So I really like traveling, and I like trying to learn at least a little bit of the language of the country that I'm going to before I go, so that way I know like how to ask where the bathroom is or something like that,
before a
Not
long, yeah,
not get completely lost. But I think it's really important to understand like the culture of the area that you're living in too.
yeah, interesting. What about each one?
I'm trying to think. So
Scholarship, everything's perfect. You got a
right.
apartment, just choose the country.
Yeah, the world opens up for me. I can do whatever I want. I can are we saying like if I could go back and start like my undergrad again, or if I could?
Yeah, if you could just
Okay.
make transition to study outside the US, study abroad, which country would you choose?
Which country? I would really love to do it in Japan, and if I could, but I don't think I could. It would just take a lot of time for me to learn Japanese and kanji and
Yeah,
everything. It would just take so much
especially
time.
study in Japanese.
Yeah, no, it would be so hard. But I would if I had I don't know if I like graduated high school like a year or two early and I had that sort of buffer time to kind of get adjusted to the language and all that. I would for sure go to Japan. That would be my first. If everything was ideal, then probably Japan.
You can teach
If
English on the side too.
yeah, see, start raking in the money.
Yeah.
But no, if that wasn't the case, then I'd probably go to an English speaking country like yeah, Australia or England, probably, or maybe even Spain, because I speak Spanish, so I could probably get away with that.
Yeah, it's interesting. Yeah, it's an interesting topic to ask people where do you like to go. How about work? Would you guys want to stay here, or do you like to work outside US?
I would, I would definitely. I think it's a that especially I moved around as a kid a lot, and I think I just now I looking back I see a lot of value in living in different places, and I think it all sort of shapes you and gives you a lot of different perspectives. So I would definitely would be interested in living in different places and working in different places for a while, but at some point I'm gonna want to probably settle back down in the US and stay at some place.
I think, yeah, I think honestly, I might try to work outside of the US because I know a lot of different countries are trying to work with renewable energy more than we are here. So I feel like that would be more of a place for me to be anyways, like a better place. Plus I like learning about new cultures anyways. That's like I've been on a bunch of like different cruises, and we go to like different countries on the cruises and stuff, and so I like learning about the place before I go, so that way I like know what's going on and understand their culture a little bit before I get there, so I'm not like completely out of place.
Yeah,
So I think it'd be cool to do that, but like actually live there.
yeah, exciting. Yeah, it's interesting.
Would you go work somewhere else or study somewhere else if you
Um,
could?
Probably Japan. I'll come with you. Get rid of
Yeah.
the apartment. I think Japan is a good choice because it's so different than any other country. It has its own thing. I don't think you can look at the other country. Oh, Japan is like that country. No, they just do everything different.
Yeah.
So it's like a when you go there, like you're gonna stay for a month or two, you're gonna experience culture shock if you like it.
Right.
But it's gonna be a big one because the food, the music, the language, everything's very, very different. But let's say if you want to go even Sweden, it's again Swedish has that Germanic language background, so it's I think again it writes in English characters, there's Latin characters, so you're not gonna have much problem learning Swedish. But Japan is like up and down, right? It's just
Japan is a different world. Like it's if you want to feel completely lost, if you want to feel like a baby again, then I'd probably go to Japan.
yeah. Even you can't even use spoons, you have to use chopsticks. Like, from the simple things, you have to do things simply. Like I think some of them like to sleep on the ground, it's just like a traditional thing. The bathrooms are different. That thing I know, it's not like United States toilet. You don't sit down, you have to squat. It's terrible. It's terrible. Your knees will go bad. Yeah.
I mean,
And
you ever
things
use a
are
porta potty before? You got to squat there anyways.
Yeah.
and things are or at least I from what I heard, it's a lot of things are smaller there compared to the US. Like a lot of things in the US are so much bigger. Just like everything, like like houses, rooms, food, obviously everything. Um, so if you were to get offered like a position in Japan in industry,
No.
what kind of position would it have to be for
Asking
you
you
to
because
go?
you're still young. Your brain is still able to learn another language. I'm too old for that. I just have to stick what I have. Start over from Japan, from zero elementary school. I don't think then that's the right choice for me.
So
You just gotta
there's no
download. You just gotta download Duolingo, and you're good.
Yeah.
there's no like offer that would entice you to go to a different country.
Yeah, I think again depends on the offer. Yeah, starting over is just I mean you're still young. That's why I'm asking you these questions because you still have like can fail 3-4 times until you land in perfect position, perfect job. But as you grow up a little older, like that opportunity becomes smaller and smaller. So you have to just work what you have. That's something a lot of people experience. Yeah.
Wow. Okay. That's interesting.
That's why I'm asking you, just explore and see what you like and what you don't like, and find that niche that you're really good at.
You feel like you did that in your time?
Yeah, I feel I did that again. I think after my undergrad, I went my own and I tried to do app development on myself, and I did a good job at it. Had an income, but yeah, it wasn't challenging enough, I would say. So, when something's very easy, something like that you're gonna do it for 20 years, but it's not that difficult, you feel like a little bummed out. Is this my life? Because you always need to get challenged. Again, let's say you take the same course for 5 semesters, just at the 5th time, just kill me. I don't want to see in this class anymore. That happens when you seeing something that is not challenging, just super boring to you. So again, I suggest to look for things, venues that you think sparks a little passion in you.
Right. And would you suggest then, because obviously there was a lot of value in learning that while you were an app developer. Would you suggest that people get a master's degree and challenge themselves right after their undergrad, or do you think it's better to have that experience that you've had?
It depends on the person. Everybody's different, right? So I can't just say, okay, follow my path. It's the first or perfect path. But you have to see like what sparks intuition in you. Where do you see yourself? Do you like to do this for 20 years, 30 years, like as your career, right? Not just for 3 to 4 years. Again, you're taking this, you're all in UCF, you're spending for 3 to 4 years of your life on something to be special at, right? So that, okay, I'm gonna be an electrical engineer. That's my character. I need to solve renewable energy problems. Even if it's a wrong choice and you have no passion for it, there might be some perks that you wouldn't have, So I prefer everybody just explore as much as possible to be focused in just one thing and just follow that through for the rest of your career, and you be okay with that.
That's a hard thing to find, though.
It's a very hard thing. That's whenever I talk to my students or my friends, they always have this problem. Like, you're not sure, are I doing the right thing? Am I in the right place? But it comes over time. When you get older, you kind of like see what works and what doesn't work, and you try to follow that. It comes with everything. It comes with your job, comes with your degrees, and even friends, right?
And there's like two sides to that coin, right? Because some people, in order to like pick something that you really want to do, it's difficult for everybody. But for some people, it's difficult because there's so many things that they want to do. And for other people, it's difficult because they can't find a single thing that they want to do. They like the one.
Yeah, two extremes, yeah.
So, talking about being an app developer, what kind of app did you create? Like, did you do multiple, or was it just one that you just continuously made better?
Yeah, so I started with some apps, educational apps. I found very soon that there is no money in it. You're not gonna make much money in creating apps that are just for. So basically, you have to know your audience a lot. You have to figure out who's gonna use that, and is it gonna be popular or not. So even if you spend so much time, this app is perfect. It's working for me. I'm using it every day. Not everyone's gonna be like you. So I shifted my gears toward creating games, kind of like games that are developed for different spectrum of ages. And I soon realized if I want to make an outcome, if I want to make this my career, I have to focus on ages between 11 till 15. These are students or childs who play the most and click on the ads the most. So if you're 24, you already know how to click cancel on the ad and just continue with your app. But if you're in that age group, you see another thing comes up, you think that's a game too, you click on it. and that becomes a revenue for the app developer. So I didn't like that. I didn't like that I'm gonna trick people to click on my ads. That was like a huge turn off for me. And I said, I don't see myself doing this for 20, 30 years. Not to say there's anything wrong with that for people who are gonna be app developers, but there's a lot of bad practice there. So again, the whole notion of creating an app is to capture attention and hold you there for a long time. A lot of apps like Instagram and Facebook are designed like that. Everything about that app is to, once you click on it, you're gonna be here for a long time. If you click on YouTube, I'm gonna show you 25 videos that you never wanted to see, but those videos intentionally makes you to go down this rabbit hole, so you stay the most and you see the most ads, and I make the most revenue of you. So this is something that I think is a little bit unethical. That's one of the reasons that I just didn't see myself doing it for 20, 30 years. So I decided just like call it quits and move on and do undergraduate.
And when you transitioned over to computer engineering, did you have to take any classes like prereqs that you hadn't taken before?
Yeah, I
because
don't
you were
think so.
electrical?
Because I had my master's too. Everything was almost done. Transition between electrical engineering and computer engineering requires nothing, I guess. But if you want to go to computer science, that's another thing, because computer science is you have to take some courses that are not offered even in both of these degrees. Yeah.
Mhm.
So, if you weren't doing like your current research right now with time series and natural language processing, what would you want to work on?
As a researcher, or just as another work?
Anything.
Both.
Anything? Both. Because as a research, even if it's not AI, I would choose. I think medical field is a big one. I think medical field has this component of using robotics, especially for people who have disabilities, using these cyber arms. Even in UCF, we creating this AI, cyber arms for people who don't have any missing parts of human body. So this is like helping someone and using technology. So I think it's a very cool field to work on. As a work, something different, I would like to choose a job that has more commodity to it. So you have much more coworkers work with you. So in the lab, again, you have 3 to 4 students alongside you. It's good, but the more people you have, the more social you are. I think that would be a much better environment to work on than just like dealing with 3 to 4 people like for 4 or 5 years.
Yeah, I get that. I feel like I have to work with a lot of people. I'm definitely a people person. I like talking to people all the time. So I can't be like sitting by myself in a cubicle. I know that for a fact. Like I'll never have a job like that.
Yeah.
And
So
you'd also, oh, my bad. You go.
okay. So you said that you really like helping people, and that's why you would go into like the medical kind of field. You collaborate with the College of Medicine at UCF, is that correct?
Yeah.
So what do you do for that? Are you doing something similar to what you just said that you wanted to do?
Something very similar to this. Hopefully, the good news will come out. I still can't talk about it fully, but what I can tell you is it's a very huge collaboration between us and the College of Medicine, and we have 3 to 4 professors that are constantly providing us with data that is very hard to get. So medical data, unfortunately, is very hard to get because you can see like electrical health records. They're like you as a patient, you probably sign a form. You don't want your data to be seen by any other company. It's your medical health data, right? This is very important. Imagine if you want to hire a company and they see that and say, smoker, cancer. They're not gonna hire you, right? It's something that it's very, very, very sensitive. So it's very hard to combine. Of course, the more data you have, you can solve medical problems. A lot of problems that we have, AI can solve them. It's again from cancer detection to making diagnosis. So hopefully we can publish that in the near future and you guys can hear about it.
And you're also doing another collaboration with the College of Education.
Education, yeah, that's another one. Again, I was a student, I'm still a student. I'm really interested in how students react, how students learn a certain topic, whether they're doing a good job or a bad job. So we're collaborating with College of Education regarding understanding your formal courses outcome. If you take Cal 1, Calculus 1, or Cal 2, what are the things that you're focused on interestingly and externally? Are you asking for the TA, or are you taking online courses, right? A lot of people like to watch YouTube and learn more about that course than just following their professor. That could be called informal learning. So we're trying to figure out what is the role of this informal learning that is kind of like new, like these Khan Academy or these courses, these online website courses are offering you free education. Would you rather just take this free education or take a formal? Which one gives you the better outcome?
Mm-hmm. And how exactly do you gauge a better outcome?
Yeah, so basically, what we want to do is have more engagement of students. Again, this is the era we're living in where every class is Zoom. Believe even in my class, I'm teaching in person and online. I think a lot of students not paying attention most of the time. So I ask them questions and I literally pull up a website. They have to answer the questions. If they're not gonna get the grade. So I'm a little evil on that side. I'm trying to make them more engaged. It's a very hard problem these days because there's distraction everywhere. And a lot of these courses, again, my course is elective. It's not a requirement, so I'm not harsh. But I feel like it needs to be improved a lot, especially from my experience. A lot of you guys are just overwhelmed with a lot of courses. Whenever I ask, how was your day? Everybody's bummed out, too much work, too much quizzes. And I think we need to find a way to solve this problem. As an undergrad, I can feel you because you're always spinning a lot of plates. You have 4 to 5 courses. You have to do well in all of them, right? And every professor asks you to just put 100%, and that 100% requires 8 hours a week. And it never is going to match. So we're trying to find a way to find this balance between engagement and are there any other alternatives than just reading the same textbook to online informal learning help or not?
Do you feel like you've noticed a change in student behavior before and after going online?
Yeah, I can tell in-person learning you learn the most because what I like to do is how I structure my courses is very interactive. There's no finals, there's no midterms. But throughout the course, every session, I'm asking 3 to 4 questions, and these are all open-ended questions for you to spark that passion to the subject. Because I know that you're gonna have 4 or 5 more courses that require the same amount of attention. So I'm trying to just use that time to teach you the most material and ask you the most material so you can synthesize that information right on the class. Unfortunately, a lot of classes, the professor comes and just go to the lecture, no questions, see you next class. And comes the final, and I'm pretty sure 85% of students don't study that program until the final because there's no requirement, right? No homework, nothing, just a final. So it's a huge toll on you. You have to drink coffee, do coffee pills, to stay up all night and make sure you do good on final. Like I don't like that type of teaching style. So I'm trying to be more interactive and ask more questions than just, again, I don't like finals or midterms. Again, if it was a required course, I'd probably put them there, but I don't like this way of teaching and evaluating your performance that, okay, come Monday, 8 a.m. and that's your destiny, right? What if that day, that hour, you were not feeling well, or you were not, didn't have much time to study? So it's not a fair evaluation, in my opinion, as well. I like to have a continuous evaluation throughout semester, so take an average of all your grades and report back.
You prefer a more diffused teaching style.
Yeah, more spread out, less pressure. There's no pressure in my course, Andrew know it. I don't like to put pressure on you. Again, if you want extension, I will give it to you. But what I want to just come to the class, and there's this notion that I always ask questions, and these are open-ended questions. They're not there to put you on the spot. They're there to just like have an open-ended question about that Q&A about that topic.
Wish my professors were like that. It's kind of nice. It's like, I mean, yeah, I like how you assess them throughout the semester and not just like the midterm and the final. Because I have classes that are just a midterm and a final, and I'm like, what if I'm sick? Like, what am I supposed to do if I'm not feeling well? You know?
Yeah, it always happens. There's the final, you're stressed, your immune system is low, you're high on
Yep.
caffeine, and you just get sick.
Yep.
I think that style also works really good for classes that are more sort of how would you say, like cutting edge or new sort of topics, because when you ask an open-ended question, it means that it's open-ended for the students, but it also is a little open-ended for the professor as well. If not, there would be like a strict answer, right? So
Yeah.
it works better for classes that are like that aren't so like traditional, or things that haven't
Yeah.
been taught like a million times.
Yeah, very interesting observation by you. Again, what courses I'm teaching is the 4,000 level electives. They're not very cutting edge latest technology. But again, if you give me a class of size of 200 or 150, and it's your requirement, I probably have to be like others. It's very hard to evaluate 150 students every class, every session, and not have any midterm, not any final, but we actually allocate 6 or 7 lectures for the students to come and show their, every student has to present 3 to 4 times. So we actually give the lecture time for them to present, for them to be participant. So it's not unfortunately possible to do that for like big classroom. And that's why you see a lot of lectures are just like that. Just print a paper, write what you know, and I evaluate you. So how is that fair? Because it's just one point of time you're capturing their knowledge. What if they're really good at the beginning and they messed up in the middle and did very good at the end? So again, these are the things that I think you need to pay attention to before making a structure about a course.
And those presentations that you said that your students do, I noticed that you have a YouTube channel with presentations. Are those student presentations that you're
Yeah,
talking
all
about?
of them are the students' proposal or presentation. Again, I just realized that since before Zoom, there was no online courses. I think it was mostly in person, so I didn't had that idea. But yeah, from now on, all the presentations will be uploaded on YouTube. These are very cool projects. Again, they are on their own. They have to create their own topic. It does not say, okay, here's the list of things you have to do. The floor is yours. Whatever you want to present, you can present. And these are to be archived, so other students in future semesters can use them as a reference and as a help.
That's cool.
Really interesting.
Yeah, it's a little more pressure too. It's gonna be
Yeah,
fun.
right?
Yeah, you gotta be on YouTube. So somebody's gonna watch you. You better make a good presentation.
Don't stutter. Yeah. Oh, I have another question. You mentioned early on that you were using your real-time systems in the machine learning to do some kind of stock market prediction models and stuff. Is that something that you did?
No, I don't like to touch stock market because it's so volatile and I mean, even for my students, I didn't give them stock market data. It's very interesting. It's a very rich data. It's every day, daily, hourly, stock market price going up, down. So as a time series researcher, it's very interesting for me to analyze that. But I don't typically, because the applications, there are much more greater applications that we can do with this time series. Again, medical field, the economy of the United States. These are require more attention than just the stock market, buy or sell or make the biggest profit. But once you know the theory about about time series, you can apply it to whatever data set you have. So in our class, we use solar data set. We give them actually 36 days of solar panels data, how they generated power, and they have to predict the next day. So that was one of my students' assignment, and I think they fairly did very well. All of them had a good accuracy.
But are there people using those models in the stock market to generate
yeah.
revenue?
I believe there should be a huge market just for finding that model. I think, in my opinion, AI can do much better than an expert, because the AI can get all those data and it can hold it. I don't know how big is your brain. You can't just remember and just all the history and try to learn to predict. That's all you do. So in terms of specializing, predicting a market, yeah, there is actually a competition that they hold every 5 years. It's called M5. I think we discussed it in my classroom too. There is a battle between who can build the best model in predicting future. So some people just like to use AI. Some people like to use pure statistics, mathematical models. From now on, I think we see AI is winning every time. It's not even close, because it's able to learn from all that huge amount of data, and which is unfair for a simple mathematical model, which is basically y equal x, which is linear or nonlinear. You're not gonna be able to capture that complex stock market behavior just by using math.
So is that like a legal thing to do though, to use an AI model to buy and sell stocks?
Being used actually in sports betting too. I mean, most of the things, right? And even those companies that they want to show the opening bets, I believe there should use some form of AI to predict what's the outcome. It's being used everywhere. Whenever it's data, you can, no matter what type of data it is, you always can use machine learning. You can exploit that machine learning models to gather some insights or some knowledge about that. So for example, for your stock market, if you want to make most amount of money, you have to buy very low and sell when the price is very high. So you build a model that can predict you the next hour, the next, let's say 24 days. And when there's the lowest, make that buy, and when there's highest, make that sell. So you have to realize every model that we build, they're not certain, they're uncertain. Every prediction comes from uncertainty. And unfortunately, a lot of models that you see, they just make that prediction. Yep, tomorrow it's gonna be $24. With what? What's your confidence? Are you 20% sure? Are you 50% sure? I'm gonna put my whole life savings in tomorrow. And we're seeing a little shift here. The models, again, whenever I try to develop a model, I try to make that confidence score as available. So you have to tell me, okay, tomorrow is gonna be $24, but I'm like 70% sure. You make a decision. Not just it's $24. And believe me, it's gonna be that. It's just not the case. You're not Oracle. You're just a deep learning model.
So based off of your financial decision-making models, have you ever made any money from them?
No, I typically against this for now on, and use my models for myself. If a company wants me, I can do it. But again, stock market is, you have to go and see. If you're just become a stock market trader, that's your life. Every minute you have to check the stock prices, because actually that's your life savings in stock market. And I have friends who are active into that, and I don't like that lifestyle, because they're checking their phone all the time, and either we're having a good time, nice time on the beach, they have to check the stock market, which is not pleasant. And this stock market is not just, you can't control it. It's too big of a problem. It's politics, it's economy, it's so many variables they have to keep track and make these decisions, which is not a lifestyle for me. I hope I never at any time of this model, because once I know if I can make money or not is either way the wrong investment just for me personally.
And at some point, it's going to be just AIs betting against AIs.
Yeah, I think right now it is so we have day trading and we have high frequency trading. Have you heard of those terms?
Yeah.
High frequency trading is like selling, let's say, dollar to British pound. So no human can do that because the prices are changing so fast in real time that you need a high frequency trading algorithm, which i.e. the AI, to make that decision, to make a sell and half a second later make it buy. So it's very, very critical and no human is able to do that. So that field is over. You don't see any courses on, okay, I want to make you you're gonna make a lot of money high frequency trading. Good luck, because the AI is much, much faster than you. But for day trading, you make a sell right now, let's say you sell it tomorrow, or you make a sell right now, you're gonna sell it 2 hours. That's much more manageable for people to do day trading. It's much more time to think and evaluate and then make a decision.
So there's already sections of trading that are completely governed by AIs.
Yeah, high frequency trading is completely governed by AI. It's been like this for almost 6-7 years. I don't think you find anybody to use a high frequency trading. If it is, just give me his number. I want to know how you can compete so fast. You have to use a model. There's no other way around it. The name is itself, like high frequency trading. You have to do it very, very frequently. And it needs to be very high amount of capital too. Like they sell like $5 million and just 5 seconds later, they just buy 10 millions. The more capital you have, the more gains you have. Because every sell and buy has a cost. So imagine like you're gonna do 10 sales and 10 buys in 1 second. It's gonna cost a lot of money.
I have one more question. So for all these, AI, machine learning, these time series, all your research and everything that you're doing, how much of it, I assume so a lot of it is coding, but how much would you say that your electrical background is helping you out? Because isn't a lot of it coding?
As electrical engineer, again, you have to learn a couple of fundamental languages like C++, C, right? And it's very low level programming, assembly. Not necessarily because of the data aspect. The data is like an object, so you better learn object-oriented programming than just CSS. So I rely mostly on high-level programs like Python. I don't think it's, when I was a student, there was no Python. There was just C, Java. Maybe Java was the highest one. Python was it was Python 2, not even 3. So I didn't know anything about Python. But as it came along, even in my classroom, I'm teaching my students Python because it's very applicable to every problem that you have. It's very general. There are many good libraries for it. So yeah, I would suggest for my students to use that. And I think for undergrad, again, I'm going to ask you 2 questions. You're asking me a question, I'm going to ask you a question. As your senior project comes, I'm refereeing a lot of people even this semester too. A lot of them are creating robots and code. There's a lot of code in every senior project that I saw. Even some students had a printer that used a lot of code. And I asked them always, like, what was the hardest part? It's not the hardware part. It's always the software part. They're feeling like they're having that much experience in coding. So that took them a long time. The hardware part was fairly easy for them to solve. So yeah, question for you, what would be your senior project if you?
My senior project, I haven't decided it yet. Obviously, I'm not there yet, but it's going to be next semester for me. But I have these notes with a bunch of ideas. But something that I really wanted to do, I really like robotics and sort of control systems and linear system theory, all that kind of stuff. I would love to make some kind of robot that can do some abstract tasks that a human could, like making food or something like that. But another idea that the people that I think I'm going to work with had is to make an autonomous lawnmower. So that might be another one, which is still, robotics. So
Yeah,
I'm down for any kind of stuff like that.
interesting topic. You can make a lot of money once that lawnmower is commercial.
Mm-hmm.
Convenient. Yeah, interesting. What about you, Julia?
I have no idea. I have like a whole nother year before I have to do like senior design projects, and I know I'm supposed to do junior design in the spring, so maybe I'll think about something then. I really have no idea, because I mean, I'm really interested in like solar and stuff like that and renewable energy. I feel like I'd want to do something along those lines, because I'm on the power and renewable energy track for electrical engineering here. Um, but I have no idea. I don't know. I'm like feeling that I'm like not creative, but we'll see. Maybe one of my classes next semester will give me some inspiration.
Mm-hmm.
It's a huge milestone. A lot of people are excited and bummed out about the senior project, but it's like a milestone. You reached it. So
Mhm.
Is there any project that you wish you saw somebody doing in senior design?
Again, whatever project you want to see, you have to figure out, can you finish it on time? Because
Right.
everything is asking you a lot of questions, and I saw some paper didn't even turn in the report paper at all. They didn't have much time. So see if it's manageable, and are you good with your teammates? This is another one. Some people like to work harder than others.
Mhm.
But I think overall, it's just use what you learned and try to build something that excites you. So we had another one who had a similar topic as you, as a lawnmower. It was a doll. This was like a robot that moves around the house, and it looked like a mouse. So it's designed for your cat to chase after and play with it. So that's kind of like a mouse that moves around the house, like a robot. It was a very interesting topic. They had like a little house that you go and get recharged. So it was interesting topic, but they haven't were able to like finish it completely. So they had that problem. So if the project is too big, it's too like, I want to do this and this and that, you're not gonna finish in time. That gives a bad review in your referee team. But I would suggest just be manageable. Start small and build it up. Don't write, okay, I'm gonna create the next Tesla car or something, and you have everything on it. Again, start small. If you think you have time, make improvement to create that wow factor, right?
Right. Well, all right. I think we asked almost every question we had, unless you have any more questions, Julia.
Nope.
You don't have any more?
More.
Okay. Okay, so I guess last question to go out. What technology are you most excited for in the future, and any final advice you have for any undergraduate or graduate students?
Yeah. First, thanks for having me. You guys were excellent, very interesting questions. I'm glad we had some conversation about different topics like future of AI, ethics, and all of that. I believe I'm very excited about general intelligence. So we're trying to build an AI that is like us, and it could be even better than us in every facet whatsoever. So we call this concept singularity. I don't know if you heard of it.
Mhm.
It's when the AI becomes more powerful than the creator. So it's interesting with time that we're living in. A lot of people think it's not going to be our lifetime. Some people, including me, believe that you might be in our lifetime. So I'm excited about that. And as an advice, I think a lot of students are doing everything great, but I know that you're gonna get overwhelmed in your career, in your studies. Try to just increase the passion now. I always focus, okay, I'm gonna go to Japan, or I'm gonna like become that. So use that passion not to increase it to the max level, so you can go through your career in your studies, whether it's your career. Yeah.
All right, that's some good advice.
Yeah, it is.
Um,
Thank you so much.
Yeah, thank you for so much for coming on and talking with us. We had a great time.
Thank you for having me, guys.